use of this, because it actually has to be enabled on each client platform. On servers, this is enabled. So if you're writing server applications, then you probably will benefit from that protection. But a lot of client systems today aren't hardened to the level that they've enabled these features. Two other features that you've probably heard of already, but worth mentioning because you need to be aware of them as an application developer, are DEP and ASLR. Now, data execution prevention is basically making use of the page permissions that we talked about earlier to make sure that, for example, the pages containing the stack cannot be executed. So you can no longer insert shellcode in your buffer overflow in the buffer that overflows the buffer on the stack. So it basically sets the executable bit only on memory pages that contain executable code. Unfortunately, for backwards compatibility reasons, this isn't enabled on all systems. So client systems still doesn't have this enabled for every process. So I won't go through which systems have which policy, but there are different policies like opt-in, opt-out, always on, always off. Always on, always off are self-explanatory. Opt-in means that a process needs to be DEP aware and say, I support this, please enable DEP for my process. Opt-out means that it's used for all processes except for certain processes that are on an exclusion list. There is a way for you as an application developer to actually enable this for your process on all systems except the always off systems, of course, which is by calling set process DEP policy API. And that's basically a one-time call that you can do in your initialization routines that will enable DEP for the whole process and will make it impossible to turn off DEP for that process as well. So you can't call it again to turn it off, for example, as a step in an attack. You also need to be aware of the nxcompat linker option, which you should be using to make sure that the modules that you produce indicate that they are DEP compatible. The other feature, ASLR, which is new to Vista and later operating systems, complements DEP by making it harder to work around or circumvent DEP. One of the easiest ways of circumventing DEP from the start was using something called a return to libc style attack. Basically, overwriting for example, a return address, forging a stack frame before it that will be interpreted as parameters to the function that you are diverting execution to. So then you could divert into, for example, the virtual protect function, and using that, turn on the execution bit for the memory pages where your shellcode lived before you jump to them. And to make that harder, ASLR randomizes the memory addresses where all executable modules are loaded on different systems. So I think there's about a byte of entropy in there. So there are about 256 different places where your module could end up in memory, which makes it much, much harder to make and reliable exploit that circumvents DEP. Like I said, available in Vista, and you need to be linking all your modules with the dynamic base linker switch to make sure that you can use ASLR on Vista. Right. I hope that was somewhat clear. If it's not, please go read the white paper. Like I said, I spent at least a reasonable amount of time making sure that the information in the white paper is correct and that it's easier to read and understand than what I'm presenting here today. This is actually the heart of the talk. This is what got me started in making this presentation. A lot of the big vendors today, like obviously Microsoft, but a lot of the big third-party vendors like Adobe, have been targeted with a lot of attacks and are feeling the need to step up their game a bit, and are starting to use these features that Microsoft themselves have implemented into Windows and into the toolchain to secure Windows and Microsoft applications, and making use of those to secure their own applications. So, for example, the kind of sandboxing I was talking about earlier, where you use, for example, a restricted token to spawn off a new process with low privileges, is something that Microsoft have used in Office 2010. And Adobe, in their new Adobe Reader 10.0, will actually implement these features, sandboxing features, and will sandbox off their PDF parser so that it will run with low privileges and hopefully mitigate a lot of the PDF exploits that we're seeing today. So, what can we learn, basically, from Microsoft's almost 10 years journey into trusted computing? Well, we can start to use these exploit mitigations that are available to us both in the toolchain and in Windows, which means that we need to be aware of them and how they work and how we need to, in some cases, enable them for our apps. And always build with the latest toolchain. If we're not using the latest version of Visual Studio, for example, the /GS stack overwrite protection will be significantly weaker than it would be if we're using the latest version. So always make sure that even old modules that you might not have changed actually get rebuilt with the latest version of the toolchain for each release. We can also read the Microsoft SDL and adopt certain practices from it that make sense in our development environments. One thing that I'm particularly fond of is actually doing architecture review and looking at your application not as an application as a whole, but as interconnected modules that each have an interface to the rest of the application, basically breaking it down into manageable chunks that we can look at and say, what are the inputs to this and how do I secure it? There are also interesting guidelines for secure coding in the SDL. For example, there's a list of banned APIs such as strcpy and memcopy APIs and stuff like that. And of course, secure, or more safe, I should say, more safe counterparts that you should use instead. So try to learn from Microsoft in that respect. They've also developed some interesting libraries and C++ templates over the years that you can also use in your applications. So for example, there's a C++ template library called safeint that can be used to basically get rid of integer arithmetic errors. So for example, integer overflows where you've got two values that you add together and the value is too large to fit into an integer and it wraps around, leading to, for example, incorrect calculations for allocations of buffers or copying of memory and stuff like that. There's also a C variant of that called intsafe.h, which is in the Windows SDK. And as I said, the list of banned APIs is interesting. It's integrated into Visual Studio, so Visual Studio will now tell you that this is deprecated, you shouldn't be using this. And there's actually, if you're lucky enough to be able to compile your code using the C++ compiler, there's something called secure template overload, which can actually take your strcpy, memcopy calls and directly translate that source code when compiling into the safer counterparts. So you don't actually have to go in and fix all your code. It can do that automatically for you. Something to check out as well. Something that I wasn't aware about until quite recently pointed out to me by a friend who said, "Oh, you're talking about exploit mitigations. You should check out EMeter." And I said, "What's EMeter?" And I was actually fortunate enough to speak to one of the developers of EMeter earlier on today, and it's pretty cool. Admittedly, it's something that might not be very useful to third-party developers, but you should at least check it out. It's very interesting. EMeter has taken some of these mitigation techniques that we've talked about that are available on Vista and above, and ported them, for example, SE hop, that's only available on later operating systems, and ported it into something that's compatible on XP as well. And also there are some features in EMeter that can enable, for example, ASLR and DEP for your processes without you actually having to do all this, be aware of all this stuff that I've been talking about before. So it can, for example, force modules to use ASLR even though they haven't been compiled with the dynamic-based linker flag and stuff like that. As I said, not very interesting to most application developers because it actually requires you to convince your customers to install this software, because it is a software package that you install in Windows that applies all these extra mitigation routines. EMeter is actually coming out with a new release, later in August. So check it out then. It will have several more anti-exploitation techniques that will break existing standard shell code, for example. Won't work anymore. It has to be rewritten. So a lot of old exploits and stuff like Metasploit won't work anymore, which is quite interesting. Those are the URLs you should check out. You can Google EMeter and Microsoft, and you'll probably get those same URLs. Actually, that's how I got them. But there's a training video there that the developer guys explain how it works. And there's also the download link on the bottom. Before I got into that brief digression, I was talking about modularizing your application. And that's one thing that I think is really important for people to understand, is that once your application grows from a simple tool into a full-fledged app, there's no way you're going to be able to look at it as a whole and understand all the interconnections between different parts of the code. So what you really need to do as an application developer is look at how can we break this down into different components, different parts that we can look at in isolation. So if we can take our application and break it down into several different parts and specify in documentation all the interactions between that module and the rest of the application, then we can actually start to look at that particular module in isolation, look at those interfaces, and do threat modeling, perhaps according to the SDL by Microsoft, or in another style that you're more comfortable with. But at least looking at these in bite-sized chunks that you can understand what the code is doing with the inputs and outputs. And another thing that you can do when we're talking about application boundaries, of course, boundaries between different modules in the code, but also boundaries between the application and the OS. You can start to look at in every case where we create a system resource, for example, if we create a file, if we create a pipe, if we create something as simple as an event flag or something like that, that we apply a safe default DACL on that object, so that we're not creating, for example, a semaphore that's wide open for anybody to gain access to and start flipping around and potentially harming or potentially changing the execution flow of our application. This is especially important if you've got kernel code in your application. If you've got code in userland that needs to communicate with the kernel component using, for example, what's it called, a named driver entry or something like that. it's very important to make sure that you've got safe